I've tried this 3 times now. I'm hoping that this actually works for lesson 15. Let's give it a shot. We have our scenario, and what it really asks us to do is to find the unit rate and then graph our findings. There's another thing that I would put in there to help us graph that would be really beneficial. It doesn't ask for it, but it's what I would do. The first piece is for unit rate. I'm going to make 3 different sections. One's going to be for unit rate. I'm going to have another for a table. And the last section will be for your graph. Now, looking at our data, we always know, well, I guess before the data, we know that on a graph and table, we have an X and Y axis. So on the table, it's X followed by Y, and on a graph, you have X on the bottom, Y on top. So when we're looking at these things, before we can really do anything, we need to identify some information. So if we go back to that problem, there's a lot of stuff in here that we don't really have to pay much attention to, but there's some certain things that we do. So we know that she's making shots. One of her important facts is she makes 20 shots every 1.5 minutes. That gives us like our information, our working numbers, I would say. Our end goal is to figure out how many shots she'll make in 10 minutes. But that's not really our goal right now. The first goal is just to figure out how does this all work, and the first thing is to find a unit rate per minute. So when you have a constant or independent, the independent variable is always going to be your x, the thing that can't be really changed. And a minute is 60 seconds. It can't be changed. So we're going to have time as your x, and then your shots as your y. Before we can start filling this table in, we got to find a unit rate. So we're going to go back to this information. We know that a unit rate is the same thing as saying y divided by x. And if we know it's time in shots, then the shots, every 20 shots is taken in 1.5 minutes. And this is what it means every single time. They can give you something like this, they can give you something like this, but in reality, it's a rate. So we have 2 different pieces. We're going to solve that unit rate. I'm going to take a little bit of space down below here to show you and to find that unit rate. So I'm going to start with 20 over 1.5. Really what that means is 20 divided by 1.5. I'm going to just take that 1.5 and turn it into improper automatically. So 3 over 2. When you do this, it's always multiplication. You do the reciprocal. Multiply across. Now, you can leave this right there. That is your unit rate. I'm going to plug that in right up here. Now, you can simplify this down to make it pretty, and that works too. It doesn't have to. So if you were to simplify this down and make it pretty, 40 divided by 3 is going to be 13.33. Either one of these is the unit rate. Now, this means the same thing. This means 13.33 shots per minute. And what this means up here is it means 40/3 shots per minute. This also can refer to as 40 shots every 3 minutes. And we're going to see that in our table here that it kind of matches up. So I'm going to bring this information up here. And let's start plugging this in. So if you have time, you have for every 1 minute, you have 13.33 shots. 2, this is the key. So let's look here. So you have 1 shot, but now you have 40 and 3. That matches up with your other unit rate. So your unit rate that you solve in an improper fraction, that's going to be the same thing as one of your inputs here. All right, I like to have 2 numbers here that are really important, or 2 numbers that are pretty big. And I guess not big necessarily, but that are clean, because it's really hard to graph a third and 2/3 and 1/3 and 2/3. So if you have a 40 and a 3, you can graph that, or a 6 and an 8, you can graph that. So now once you have this table, then you just bring it over your graph. Bring in your numbers. So please excuse these 2. This is from another previous attempt. If I was looking at this, my first number, I wouldn't graph the 1 or the 2. I'd jump right down to the 3, and it would be 3 and 40. So I would go over to the 3, up to 40, make my mark. And then again, I wouldn't be looking at the 4 or the 5. These are really hard to graph. But the 6 and 80, this is really easy. Again, I go with easy again. So go to 6, go up to 80, make your mark. Now remember, this isn't exactly perfect, but should be pretty close. So if you line this ruler up with these different marks, you should see that it lines up with the 0 really easily. I'm going to draw a line in here. And that's going to indicate our line of travel. So as this increases in number of minutes, you should be able to have a very consistent line going up. Now here's the thing. It asks us, if we go back to the original question, it asks us for 10 minutes. And we haven't found that yet. We've gotten to 6. You can do different things. You can look in your table and add 6 and 4, and that could work. But if they ask you for other numbers later on, it's better to create an equation. They don't ask us for the equation, but it is better. So you're going to plug it in, y equals, and remember this is constant of proportionality or unit rate, and then x. Your x, you got to remember what these things stand for. So your x and your y stand for certain things. Your x stands for this bottom row, and it also stands for minutes. The y stands for the vertical piece, and this stands for shots. So depending on which one you want to try to find, then that's the one you plug in. In this case, we know that she ends up shooting for 10 minutes. So all we have to do is replace this with our unit rate and replace this with the number of minutes. So let's do that. Y, I'm going to replace it with my fraction, so 40 over 3, and then 10. And then from there, it's just a multiplication problem to find how many shots it equals. And then I'm going to cheat here. I'm not going to do the actual math. I did it on another piece of paper. You would end up with 133 and 1/3 shot per 10 minutes.